So today we're going to talk about, or this week we're going to talk about bivariate analysis. That is to say, the relationship between two variables. And there are several ways you can do this, and some are qualitative in nature, and some are quantitative in nature. And qualitative measurement would be a measurement that just sort of shows you the qualities between two variables, and not really giving you any specific numbers and how strong or weak that relationship is. Whereas a quantitative measurement will actually give you a hard, fast number and showing you how strong or weak that number is. So among those measurements that we're going to talk about in terms of methods to assess the variables' relationship between one another are contingency tables, scatter plots, and correlation coefficients. This topic today is specifically about contingency tables. They're often referred to as cross tabulations or cross tabs. Sometimes, depending on the number of categories, you can see them as referred to as 2x2 tables. Essentially, all you're looking at is two variables, one going across rows and one going across columns. And specifically, you're looking at data from the independent variable, which is your exposure variable, and the dependent variable, which is your outcome, looking for possible relationships. For example, if you're looking for a relationship between, say, education and homelessness, a very common question in social sciences, then your education would be your independent variable, your exposure, and your homelessness would be the dependent variable. If the research question was, does a lack of education have an effect on one's future homelessness? If there is in fact a relationship between education and homelessness, then you'll see that as one of those variables changes, so too would the other. In other words, the more educated someone is, the less likely they are to be homeless, for example. Or, for whatever reason, the less educated they are, the more likely they are to be homeless. If there is no relationship, then as one variable would change, the other would not. So the more education one has no impact on their homelessness risk. So here is a contingency table set up. It's essentially, again, it's the independent variable or the predictor variable, and the dependent variable, which is your outcome variable, and then exploring possible relationships. And I've just made a very simple example here of gender and coffee drinking. So let's just talk about some of the overarching issues for this table. Initially, I want to point out is that the exposure variable here, or the predictor variable I have, is gender. I'm just looking at say this is a research question looking at whether, I don't know, being a male, it has an impact on coffee intake rather than being a female. Or do males drink more coffee than females? So something along those lines. So you'll notice here I have a bracketed out just so you could be aware. Gender here is a nominal variable. The nominal variable is a variable in which is a name in nature. It's a nominalis, meaning name. What that basically means is that the categories of the variable cannot be ordered in any way, and that they're just simply names. So gender is a very, very, very common nominal variable, and so is, say, race or ethnicity. Very common nominal variables are variables in which the categories themselves are simply names and cannot be ordered. Ordinal variables, however, are variables in which the categories can be logically ordered. So here I have very few cups, a few cups, or more than a few cups. There's a number of variables that can be ordered just like this. You could do education, where you could have less than high school, or more than high school. You could even have, say, cholesterol, less than 200, 200 to 250, and more than 250, something along those lines. So an ordinal variable is a variable in which the categories can be ordered, hence the term ordinal, ordered. So lastly, we also have something called a marginal total. Marginal total is just a column or a row in which we are adding up across columns or across rows. For example, here I have 20 students, and that 20 students is simply adding up 12 plus 3 plus 5. I have 10, which is simply 1 plus 3 plus 6. And then I have 13, 6, and 11, which is these columns added up across the two rows. And if you did it correctly, then these two numbers, to 20 and to 10, should add up to the total sample size of 30. And this, 13, 6, and 11, should also add up to 30. And in this case, they do, so we know we did it correctly. But generally, what you're going to have the base of the contingency table will only have 12, 3, 5, 1, 3, 6, and then later you can add the marginals. But the marginals are important to know for future tests. And here I'm just pointing out that your total number of respondents in your study should be easily depicted in the corner table right here, the corner cell. So looking at just the raw counts, or the absolute frequencies, also referred to as absolute numbers, don't really tell you much about the relationship. So if I just look at these numbers, 12, 3, 5, 1, 3, 6, I really can't tell you whether there's a relationship between gender and coffee intake. I have no idea, because quite frankly, the numbers themselves, I mean, you have to really compare the numbers to, say, the overall number, or the row number, or the column number, the column total, the row total, or the total sample size. In other words, essentially, absolute frequencies in so many ways are really not helpful whatsoever. And so what you really need to do is do something called a relative frequency. So when I said I needed to compare them, I really need to make a relative comparison between, say, 12 and this 3 and this 5. Now, this 12 is a lot bigger than this 3 and 5, but is it different necessarily relative to the categories? And that's how we're going to do next.